Hey guys, Mr. Myers is here, and in this video we're going to talk about the shape of a distribution. So how do you describe the shape of a distribution of quantitative data? So let's take a look. The first thing you want to do most of the time is talk about the modality. So how many modes does it have? And we're really looking at just the shape. So we're looking at the distribution itself in terms of maybe a histogram or something. Now, these data here, notice that they are unimodal. So this is one mode. One mode basically means that it comes to one peak. And we don't know in this histogram how many modes there actually are. So just because something has like 3 modes doesn't make it not unimodal. Really, we're looking at the distribution as having, maybe you can see me here in this little tiny screen in the corner here, that having one mound, one peak. Okay, that's unimodal. If it has 2 clear groupings, 2 clear groups, now those groups don't have to be exactly the same. They could be like this, but they have to have basically 2 groupings of individuals or of data. That's called bimodal. So that's bimodal data. Now, if you have multimodal, you just have multimodal. That could be more than 2 modes. But if all of the data are the same, so everything is relatively the same frequency, then that's called uniform. So let's take a look at another thing that you have to talk about in terms of the shape. These are probably the more important things. So in the shape of a distribution, you have to talk about whether it's symmetric or skewed. So symmetric distributions have the mode right in the middle. So you're looking at something that has a little bit in the left. Most of the data are right in the middle and a little bit of the data on the right. So it just comes up and it's kind of bell-shaped. So that's symmetric. So going back to this other one over here, the first one that we showed you was unimodal and symmetric. So because it's kind of, it's most of them are about the same on the left and the right, so that would be symmetric. The next one would be skewed to the right, or a right skewed distribution. And in a right skewed distribution, most of the data are down here in the lower end, and you have a few up here on the top end. This is called the tail, by the way. If you draw, I like to draw a little, I can't really draw on this screen right here. I don't think I'll be able to draw here. So let's see if it lets me draw. Maybe the pointer tool. Let's see if you can see. I put little eyes here and a smiley face, and there's its tail, right? The tail right there is on the right of the graph, so it's right skewed. Left skewed distribution. Left skewed would be the tail on the left. So more of the data here are on the higher end, and a few of the data on the low end. So that would be a left skewed distribution. So let's take a look at some examples of where we'd have the modality in terms of the unimodal, bimodal, or uniform, and then the symmetry. So let's take a look at a few examples. So the number of speeding tickets each student in a senior class of college has ever had. Well, if you think of this contextually, like all of these, you're going to hope that most students have like 0, 1, 2, maybe 3 speeding tickets, maybe more like 0, 1 range. And then you'll have a few with like 15, 10. Those are really bad drivers, speeding all the time. Those are going to have lots of speeding tickets. So you're going to have more on this side and less over here. And so you're going to have a skewed to the right distribution. All right, we're going to skip to, now, I know some of you are golfers out there, but a lot of people don't know the golf score, so we're going to skip the next one. Weights of female babies born in a particular hospital. So if we're looking at the weights of babies, most babies weigh about the same amount, same weight. Some babies, premature babies, are on the lighter end. Some babies, the big babies, are on the big end, and we've got most of them right in the center. So this is going to be unimodal and symmetric. I'm going to think it's going to look kind of like this, unimodal and symmetric, okay? Let's take a look at another one. The average length of hair on the heads of students in a large class. So if you look around in a class and you think about who's in a class, you've got females and males. Most of the females have long hair. Most of the males have short hair. Now you've got some overlap, but for the most part, you've got 2 clear groups of people with the hair length. So you've got long hair, so you've got a group over here with long hair, and you got a group over here with short hair, and so that is going to be a bimodal distribution. Now, I don't know if it's skewed left, skewed right, or symmetric. I would really need to know the makeup of the class, if there are the equal amount of males and females, if there are more females or more males, to really know if it's going to be skewed left or skewed right. Let's take a look at some more examples. Ages of people at a Little League game. So for any of these, you might want to just pause it for a second, think about it, and see if your answer comes up to be the same as what I would have. So for ages of people, Little League game, it says ages of people. What kind of people are a Little League game? Parents and kids playing the game. So you've got two groups of types of people there. So again, you're going to have bimodal distribution. What about number of siblings of people in your class? Well, most people have around 0, 1, 2, 3 siblings, and then you've got a few that have 7, 8, 9, or 10, right? So you've got a lot of people on the low end, a few people on the high end. So it's going to be up here and then down way over here. That's a skewed right distribution. We'll skip that one. Number of times each face of a die shows in 100 tosses. So 1, 2, 3, 4, 5, 6, they all have an equal chance of showing up. We would expect these to show up about the same amount of times across 100 tosses of the die. So this, since the frequency is about the same, this is a uniform distribution. There's my bad math pun joke there for you. Uniform distribution if they're all the same height. Okay, all the same frequency. So there you go, folks. That's basically what you need to do when you describe shape. You need to describe the modality, either unimodal, bimodal, multimodal possibly, or uniform, and symmetry. So it's either going to be symmetric, skewed left, or skewed right. We're done. We'll see you soon. Bye, guys.